OK, so we have 20 minutes to cover the rise of the AI engineer. It is a thesis I've been developing for the entirety of the past year. It's coming true in some sense. If you're still here, you're at least somewhat interested in it. I'll attempt to do justice. Don't worry about. I'm going to go very fast. If this is the first time being at one of my talks, you know that I speak at the rate that I listen to podcasts on, which is at 2x and sometimes 2.5x. But all my notes are on my website, as well as on the latent space if you just search Rise of the AI Engineer. OK, so we're going to have three parts. The first is just presenting some data. If you've been somewhat living under a rock or you've been overwhelmed by too much info, these are the ones I want you to have in mind. AI is the Moore's law of our time. These are all sort of progress metrics in the past 10 to 20 years. What you have on the left is the image generation capabilities that we've had developed over the past 8 to 9 years. In 2014, we used to sort of develop this sort of grainy picture of a face, and now we complain if we can't place our dog in the middle of a generated image. In 2000, we barely solved handwriting recognition with the MNIST dataset. And now we can mostly are at superhuman levels in quite a few core human capabilities that we understand. But it has also caused a lot of AI madness. This is where I tend to distinguish myself from some of the sort of AI hype beast people that you might see online. So a lot of people are sort of mentioning AI and then trying to have some kind of AI strategy on their earnings calls, but there's very, very little usage actually, and there's still a lot of stuff to be proven out. And in particular, one of the most impactful or one of the most hyped projects of the whole year is AutoGPT, which if GitHub stars are to be believed, is more useful than PyTorch, Bitcoin, Kubernetes, and Django. It's pretty crazy to have that, and then to have other people also commenting that no one's using this thing, which is really interesting. There's also sort of, I call this sort of manic depression. In the same month, you have investors saying that AI has peaked and then also AI is back. If coming from San Francisco, it's very, very common to simultaneously have the feeling that something is so dead and something that's so back at the same time. And this is all short-term momentum against the backdrop that we are in a longer arc of history, where we're just sort of inevitably marching towards sort of like a bootstrapping of a digital intelligence that will surpass us within our lifetimes. And like I would say, like it's very popular to blame like sort of short-term impacts on AI. Chegg is one of them, but I think for me where it is easier to keep up. It's not in sort of all the papers. Like I have a monthly recap on Latent Space, my newsletter, where I sort of recap like the top things you should know as an AI engineer. But really, it's just follow the money. Like that's it is the least worst form of figuring out what is valuable that we've developed in the time that humanity has been around. So who's doing a good job? Who's actually making money? Jasper's arguably not doing as great right now, but they still went from 0 to 80 million ARR in 2 years. Generative Images, Midjourney is now reportedly at $100 million ARR with a team of only 13 people. Coding assistants, Copilot now has reported $100 million ARR, and chatbots, obviously, OpenAI has $1 billion just on ChatGPT alone. But also, like not just those big companies. I think there's a lot of opportunity for indie developers, both solo developers. Obviously, Peter Levels and Danny Postma here are really good examples of that. If you want to follow those names and read up on their stories. So that's just like some data points that I want you to have in mind. That AI is real. AI has a lot of opportunities. There's a lot of overhype. There's a lot of hype, but there's also some real long-term progress here. And the real central thesis that I want to deliver is that there's also an industry that's being formed as we speak. And a lot of them are going to be people crossing over from React and JavaScript, just like myself. This is all sort of summed up in this thesis, The Rise of the AI Engineer, that I wrote a few months ago. And the central thesis is that AI is shifting right? Like this is an actual XKCD comic from 2013 where they talked about like, oh, if I need to do bird recognition, I need 5 years in a research team. And now you sort of grab models off the shelf, you prompt them a little bit, and just a little bit of prompting can take you from like unimpressive performance, like 17.7% zero-shot performance, up to state-of-the-art 78% on some metric. And that is a very, very different state of AI as it is today. Like from hey, you need to hire a research team to hey, you just need to prompt a little bit. That is a huge shift in the past 10 years. And the starting point for AI has moved. So here's a screenshot of a Hacker News thread on how to break into AI engineering. And these are the top 2 answers that I saw. First answer is do all the machine learning stuff, right? And I've done these machine learning courses on Coursera. Not helpful at all. They're sort of the previous paradigm of machine learning. The second answer is I'm sorry, it looks like the screen has gone dark. The second answer is that you should do data engineering. And I spent some time doing data engineering too. I also thought that, oh, maybe AI is just all about like setting up data pipelines and setting up your data warehouse and learning from those. And after having done that, I also feel like it's not really super helpful for me to understand all the sort of foundation model progress of today. Should I pause to get the screen back? What are we doing? OK. I think the AV team is still figuring it out. Give me a sign. Anyone? OK, cool. All right. I'm not sure what's happening here. Like it's still kind of it's still playing on the screen over here. So I'm just gonna try to keep this moving without screen assistance. So I want you to imagine in your head a spectrum from left to right of the roles in a sort of AI-enabled organization. So on the left you have the sort of ML side, and on the right you have the product side. On the left you have sort of ML researchers, ML engineers, and then on the right you have full stack engineers, front-end engineers, product engineers. And in the middle, there's sort of this dotted line that's basically the API line. And what effectively is happening is that the ML research org and the ML engineering org is being now productized as AI APIs, effectively, that you can sort of grab these things as a service and call them, or you could just kind of work with them. And the full stack engineers who are working on these APIs are going to specialize into a dedicated role that I'm calling the AI engineer. So that's the sort of mental image that I would show on the screen if we had time. Yeah. Are we fixing that?
The projector lamp died. They're replacing it.
OK. All right. Some things cannot escape the physical layer sometimes, but it's OK. I can sort of improvise. So we'll roll with it. You know, like I think a lot of times you have to do sort of error correction in life, and there's a lot of stochasticity in dealing with in both data and sort of messy hardware issues. So all right. 5 main reasons for the rise of the AI engineer. So I'm gonna really sort of enunciate and try to over-elaborate because you don't have visual aid. So it's going to be economics, it's sociology, it's tech, and it's product, and it's language. And in terms of economics, there's simply straight up not enough ML engineers in the world. The reasonable estimates, about like let's say 50,000 ML engineers in the world, and there's something like 50 million developers in the world, right? Like, and the sheer demand for AI stuff, it means that there will not be enough people going through the same sort of ML engineering career path that you might want to hire out of that path. So just like sheer demand and supply-wise, there will be a sort of secondary role to the ML engineer that will emerge that will do adjacent, just slightly different things. And the quote that I featured on my slides, which you cannot see because the lamp died, is one from Andrej Karpathy, who was sort of commenting on the rise of the AI engineer. And he said this, which I really love. He said, in numbers, there's probably going to be significantly more AI engineers than there are ML engineers. One can be quite successful in this role without ever training anything. And I think that's the main dividing line. Are you training models or are you not training models? Are you putting the models to use? And I would say the role of the ML engineer is to help to train models and help to serve them. And the role of the AI engineer is that, all right, once you serve them as an API, how do you take advantage of them and consume those APIs and deliver the last mile to the users? And it's so fascinating to see, to look at the sort of roles and the surveys out there and to see like ML engineers are sort of this thick bar, AI engineers are this thick bar, and to have an understanding and a high conviction that over the next 10 years, that ratio will flip, that there will be more AI engineers than ML engineers. It's also economics in terms of just underlying hardware. Hardware is hard. Things break all the time. But primarily, I had this slide that was basically showing all the GPU hoarding that's happening by all the big tech players. Now there's a term for this. It's called the divide between the GPU rich and the GPU poor. Most of us are GPU poor. In fact, I have a little hat back home that reflects this. So people like Inflection, Mistral, Reka, Poolside, Contextual, and of course OpenAI and others are all just like hoarding all the GPUs in the world. There's only 500,000 H100s produced per year, and most of these things are already spoken for the next 5 years. So if your plan is to build your own ML research team, build your own models internally within your company to take advantage of AI, it is not physically possible. But you can take advantage of the APIs that are being served, and I think that's why the sort of relative role of the AI engineer will arise. The third piece is sociology. I have this, again, I have to sort of illustrate this chart. A lot of the, so I'm advising for a few startups, and a lot of the startups are not traditionally AI startups, but they're sort of discussing AI. So typically in like the Slack channels, there'll be like I have this like literal highlight of a channel I'm in that is like, discuss AI, right? Like, and people just kind of enthusiastically throw stuff on the side. My thesis is that those informal Slack channels will become formal teams. Whoever is sort of active and leading the discussions in those channels will formally start teams on their own. And this already happened in my previous company. So this is like not even a prediction. It's just a description of what is happening live today. And so that also happened for me. I run a Discord for DevTools investors where AI and ML used to be like one line, and now it's pretty much half the channels that we discuss stuff in, and I think that's a reflective of how these sort of social evolutions go on. You start informal, what you do on the nights and weekends becomes what you do in your day job. And then the next point, I think it's like third or fourth at this point. It's also enabled by tech. Like I'm not making pure economics and pure sort of contingent sort of commentary on like why the AI engineer will rise. It's also enabled by fundamental advances in technology, right? Like what I would have shown you here is a few things. One, you should read the GPT-3 paper. You can also read the Segment Anything paper that came out of Meta, and finally you can read any number of the prompt engineering pieces. I think mostly Kojima et al. From that sort of, which is the Let's Think Step by Step paper. These are all examples of in-context learning or zero gradient learning or zero shot transfer, all of which are basically unlocking capabilities that are trained within foundation models already. In other words, you don't have to be a model trainer to unlock capabilities. You can actually just prompt or do other similar activities to prompting to unlock those capabilities. And I think that's very fundamentally different than the previous era of machine learning, where you had to specifically say, like, all right, I want to detect fraud, so I will train a machine learning model and serve it to detect fraud. Very, very domain specific, where here it's like, some other lab is going to spend $500 million upfront to train GPT-4, and then we'll sort of use it in a domain specific application by prompting it. So there is a fundamental tech shift, and I'm not sure if I can illustrate it well without, but I'm going to try to do that anyway. Okay, second last one, I lost count, is a product shift. So I also think about things in terms of like being a PM, being a business person. Traditionally, the machine learning process is you collect a whole bunch of data, then you train the model, and then you serve it into your products, and then maybe you improve things by 2 to 3% in terms of your recommendation systems or your fraud detection or whatever. And that's the traditional sort of path of the data and ML engineer. What happens with LLM-enabled engineers or foundation model engineers or generative AI engineers is you ship an MVP first. Then if the MVP kind of succeeds, then you get a bunch of data from real users. Then you fine-tune your model to serve that. So instead of the ready, aim, fire approach, you are now fire, ready, aim. And that shifts a lot of the time to market by orders of magnitude. And I think that is if you're in the startups world at all, if you're into sort of the agile versus waterfall approach at all, this should really resonate with you in terms of like the time to market argument of how AI engineering can really shift things as opposed to ML engineering. And finally, for this crowd, this is the best crowd to talk to it about. There's just a demographic shift. ML was very Python, and now AI being available through APIs is available to JavaScript people, so everybody here. And so like different estimates occur, but effectively, I think the JavaScript population is about the same size or maybe slightly bigger than Python. So we've effectively doubled the TAM of AI engineering. So I'm just going to recap. 5 overall reasons for the rise of the AI engineer. 1, economics, which is GPU and people. 2, sociology, which is the intrinsic desire of people to want to explore informally and then formally. 3, which is tech, fundamental improvements in foundation models, zero gradients, and in-context learning. 4th is products, shifting from ready, aim, fire to fire, ready, aim. And then 5, which is language, just the demographic shift from JS people being able to take advantage of AI finally instead of just Python. And so I have this whole section on Software 3.0, which I can't really talk about without slides because I was trying to show you some code. But you can check out the thesis on the essay. If you just search the rise of the AI engineer, you should see it. But basically, the whole thesis is that AI with code is more powerful than AI with language. And I'll tell you a personal story of like why I got this realization. So I host a number of events in San Francisco, and some of them are just like sort of social events. Some of them are more sort of tech demos. And at one of them, I had a woman come up to me and she was like, "I'm all in on AI. I'm trying to sort of learn everything, but I'm not technical. What should I do?" And I gave her some usual tips about like, okay, you should learn Midjourney, you should learn prompting and all that. But ultimately, I realized that like the people who are best positioned to benefit from this sort of AI wave are the people who can wield it via code, because with code, you can orchestrate your prompts, you can orchestrate your chains of prompts, and that's why LangChain is very popular. And you can use your language models to generate code to do other things. And all of this are sort of locked up behind a wall to non-technical people. And so, answering Mehdi's original question when he was talking about like, is AI going to take our jobs? I would actually posit that AI is going to be the job that takes away the other jobs. So if you believe that humanity has no other desires and will buck the trend of continually being wrong about technology taking away jobs, then AI will be the last job to be automated. So I've sort of worked out that logic internally, and I'm pretty comfortable with this philosophy. Okay, so I'm going to skip a lot of the charts that I show typically in this demo because there's nothing to see. I will just instead direct you to the AI Engineer website. So if you go to ai.engineer, yes, engineer is a TLD, and yes, we bought it. It actually shows you a nice little survey of the central problems of the AI engineer. I think every industry that is forming, just like data engineer before it, just like front-end engineer before it, just like DevOps engineer before it, I've studied a lot of these sort of industrial shifts, and I think AI engineer is one of these industrial shifts. Every industry has a shared set of central problems that everyone gets together to discuss, share solutions to, and try to advance the state of the art on. And I have about 6 of these that I've identified. So I'm just going to go through some of these, and then we'll go for Q&A because I'm clearly not doing as good of a job. The lamp doesn't like me. So first is AI UX. And this is where sort of React and front-end engineers do really, really well at, which is how do you translate the raw capabilities, the sort of model parameters, into UX that disappears under the hood. And many of you are familiar with Amelia Wattenberger, and she came to my conference to speak about this. A lot of people are basically trying to see beyond the chat box, right? Like ChatGPT was mostly, OpenAI is very fond of saying that ChatGPT was mostly a UX innovation on top of GPT-3. And if that's true, then fine. They added a chat box and it became the most popular product in the world. But how do you innovate beyond that? Because a chat box is just a very sort of brutally empty state, and it doesn't really provide any affordances for people to discover what that looks like. So Amelia Wattenberger, in her talk, I highly recommend seeing that, basically shows ways to toggle on and off different modes, and ways to build affordances for you to sort of enhance, to utilize AI capabilities without actually typing in prompts and stuff. And also, I think one of the things that she's working on that's very interesting at Adept is everyone's talking about this concept of AI agents and how things you can sort of you can employ AI to do things for you autonomously. But a lot of AI agents today take the form of a floating text box on your desktop, or as a Chrome extension within your browser. And I think that's also still not exactly what we're looking for. It's not like we're gonna like open up a website and go like, all right, I'm trying to buy plane tickets to New York, so I'm just punch it in there, and then it just automates the browser for you. That's the state of the art today in AI agents, and that's not really inspiring or useful. But what she showed in her talk, which I highly recommend, which is just kind of running everything in the background as though it was like a table, and the agent sort of disappears, like the sort of AI experience disappears. And that's what innovation in AI UX could look like if you're interested in that. I'm going to briefly go through the others, but you can also see more at ai.engineer. It's AI engineering tooling, so that's the LangChains of the world, the vector DBs of the world, as well as the evals that you might want to see. Third is AI productivity dev tools. Here's where all the co-pilots and the sort of code assistance AI tooling is, because I think we need to sort of improve our own productivity before we can help others. Fourth is OSS hosting and infrastructure. So a lot of these sort of top-tier models are closed source, but open source is also progressing along, and you might need that for privacy, customization, and other reasons. Fifth is fine-tuning and post-training. And here's even more technically advanced open source hosting. And sixth is AI agents, all of which I cover within the sort of AI engineer curriculum. So I have a whole list of tools. If you want to talk about tools, we can talk about it in the Q&A, but I'm just going to skip over all of that. My last, I guess, call to action without the slides is there's just a lot of content and a lot of detail. I would just say that if you understand the core 5 reasons why AI engineering is becoming a thing, you can decide for yourself whether or not you want to become an AI engineer, you want to hire AI engineers. You can decide if you like the scope of the AI engineer is something that you're interested in building, and let's talk about it. I have the podcast and newsletter at latent.space. That's where all the sort of AI conversations happen. And if you want the conference and workshops that I do, it's at ai.engineer. So thanks for that, and I'm happy to take questions.
Thanks a lot.